Guys, how are you? I'm back with another video on the statistics and research methods used for psychology for UPSC preparation. This will be one of the most important videos I will post because this contains some of the topics which are most dreaded by the aspirants. They are not able to understand properly, mainly because these topics are not present in a detailed manner in the standard books or standard textbooks. Okay, but before starting, there is a disclaimer. Okay, I would be explaining these topics and I'll be explaining them from the basics. I'll start from very simple examples and very simple, and which will be very simply understandable by people. But I might go somewhere in a little bit of mathematical detail. Those who are able to understand it, it's fine. That's great. But those who are not, do not worry. Skip it. Okay, you just need to understand what that particular term means. All right. Okay, so let's begin. So we have completed almost everything in chapter 2 and 3, which I like to call together as the research methods chapters. The only thing that's left was this Ttest, as you can see. Then ANOVA, regression, factor analysis, and item response theory. Okay, and sometimes once in a blue moon, they UPSC also asks questions about packages like SPSS and some statistical thing like they might give you a case or something. But of of late, after 2012, they have stopped asking. So maybe whatever I'm telling you right now might be very difficult uh, before this, before seeing this video. But even if it becomes simple after seeing this video, there is very low chance that they will ask any of this. Okay, but this chapter is like that. I mean, if you do not do it, you feel like you are missing something in the syllabus, and if you do it, then it gives a confidence, right? That kuch bhi aayega likh denge, right? So that confidence is sometimes necessary, especially to calm down the nerves. But I highly doubt that they will ask any of this. And if at all they ask, they'll ask very simple things. Okay? So let's begin with the first topic. It's called Ttest. They have asked multiple times. Okay. Okay. These are all statistical concepts. So don't worry if you don't see my face, you just have to concentrate on the board. I was not using a board for any of the previous videos because it was not needed but for this one I needed it. Okay, so Ttest is what? It's basically a method to tell whether two groups or your two results are significantly different from each other or not. Okay, so okay, before explaining these things for the benefit of people who are new to statistics or are from a non-maths background, I would like to explain a few things. You know what a mean is? Mean is simply the sum of, so let's say if you have the IQs of all people in your experiment, right? Somebody's IQ is 200, somebody's IQ is 80, 160, and so on. Okay, so you sum all these and then you divide by the number of observation. That is your mean. I know this is very simple, but don't worry, people who are finding it very simple, I'll go into really great depths. So at that point of time, you might not feel simple. This is for the people who are actually want to start from scratch. So mean is basically so the summation the sum of all this we write it as sigma, right? So let's say if this variable is called IQ, let's call it x. So it would be sigma x or sigma xi, where I is equal to 1 to n. So and divided by the number of observations, n. Okay, don't worry. So mean we generally denote by a Greek letter called mu. Okay, mu, mu. Okay. Now Ttest is a method in which you try to find out ki whether one group, you found two groups, now you are trying to find out whether one group is really significantly different from other or not. Okay, so let's take an example to explain you the whole concept behind it. So let's say if you are a psychologist, you are conducting an experiment on cultural basis, right? And in the so you are trying to see whether um, analytical intelligence is more in one culture and in the same so there are two components of intelligence. One is analytical, some people say, and others say it's holistic. Some also write it as WHO. Okay, but I'll write it as holistic, H. So there can be two components, analytical and holistic, right? Now you are doing study on culture A and people of culture B. Okay, here are many people. Now you give them some tests. They have test scores, right? Now let's say the here we write the test scores of A, test scores of B. Okay, in let's say only in analytical intelligence. We are just talking about analytical intelligence. Okay. Now you got the scores. Let's say 120. It started with 85. The mean of this you got as 100. Okay, but the mean of this, that means people in culture B, the mean analytical mean, I already explained you what it is. Mean analytical culture, mean analytical intelligence you got for culture B as, let's say, 95. So can you just by looking at this data tell that the people in culture B have lesser analytical intelligence than people in culture A? It is a very difficult question to answer. To answer such kind of questions, we use Ttest. Okay, so it actually tells you that whether whatever means you have got or whatever numerical values you have got about a certain set of data in two things are actually they make sense or they are just due to chance, right? ऐसा भी तो हो सकता है ना कि इसमें से एक बहुत ही भोंदू आदमी है एनालिटिकल इंटेलिजेंस में and his IQ is 20, whereas the rest of the people here are 140, 140. But this guy has pulled down the IQ, right? So you cannot say that the average IQ of people, you can say in numerical terms, but in general terms, you cannot say that some people in culture we have lesser analytical intelligence. You cannot say that, right? It would be a um, wrong proposal to make, wrong theory to arrive at. So, in order to do this, what we try to do, abhi dekho, you understand that if there are extreme values in this data set, then it may affect your mean here and which may give you faulty representation. Okay, for those of you who are in the habit of seeing. Okay, so now you understand that extreme values will give might give you wrong uh, interpretations. Okay, so so we have got an idea that the extremeness in the values should be reduced or should be looked at before arriving at the conclusion. Okay, so that is within the group the extremeness of value should be seen. And also there is also one more factor, which is the difference between the means. No matter how much you are skeptical about the data set, बट अगर इसका मीन ज़्यादा आ रहा है और इसका मीन कम आ रहा है, देन भाई कुछ तो बात है ना कि इसका कम आ रहा है बी का. सो वी ऑल्सो हैव टू टेक इनटू अकाउंट कि इस दोनों में कितना डिफरेंस है. सो सो अ टी टेस्ट इज नथिंग बट a combination of these two things which I told you. So it measures the, so t value would be, t value basically aims at finding a t value. Okay, so t value would be this extremeness in the data set is actually, in statistical terms it's called variance. Okay, variance, like mu, mean is denoted by mu, variance is denoted by sigma square. So this is a symbol of sigma. Okay, it's like 6 but rotated clockwise. Okay, so it's sigma square is what I'll write it properly for the people who are not aware with such terminologies. Okay, so it is variance is called sigma square, denoted by sigma square, and this is a measure of your extremeness. Okay, so extremeness within the data will be measured by this. So T-test is one thing upon the other, and the thing which is on the numerator is the difference between these two means. Okay, so you can write it as mu A minus mu B. Okay, the modulus that when I write this, this means you actually remove any negative signs if it is there. Okay, so if the value is minus 6, you take as 6. Okay, if it is plus 6, you still take it as 6. Okay, so this mu A minus mu B divided by the variations within these two, right? So you have the standard deviation. I told you, okay, so okay, this is variance and it is denoted by sigma square, right? Now this is a square of something, and that something is nothing but your standard deviation. So variance is sigma square and standard deviation is your sigma. Okay, what is standard deviation? I can explain it to you. So how you do it? So there are individual values here, right? 120, 80, and all. So you take one value, subtract it with the mean. Okay. Similarly, take 120 subtracted by 100, it would be 20. Then 80 minus 100, it would be minus 20, right? You square all these values. So here also we got 20. Here also we got minus 20. And similarly, we got all these values, right? You square these values. Okay. And then you divide those squared value, the sum of these squared values by your, okay, let me put it like this. So you divide the sum of those value, you divide the square of the sum the square of those, right? So you calculated 120 minus 100, 80 minus 100. Similarly, it would be 40, 40 minus 100, it would be minus 60. Okay, you square these values, you sum all of them. Okay, so that would be so it would be 400, 400, and 3600. Right. So and then that would be around 4400. And similarly, you keep on adding things, and then you divide by the number of observation that is there. Okay. So in a way, I can write it as sigma xi. I means ith. So if it is first, then I will be 1. If it is second, I will be 2. I minus mu whole square divided by n. N would be the number of observations. Okay. That is your standard deviation. Now this standard deviation is a measure of the variance, right? As I told you, if you square the standard deviation, you will get your variance. So if I square this value of standard deviation here, it will give me variance. Okay, so sigma A square means variance of the data set of A. If I divide it by n and then do a similar thing with the variance of B. Okay, and if I put a square root of all this, you will get this t value. I know it became a little complicated, but if you did not understand the math, do not worry. They will never ask you to write a formula or give you to calculate. But I have explained it in a very step-by-step manner, so I think that should be easy enough for you to understand. And if you do not understand one time, just rewind the video or seek the video where it started, and then again try to understand. So you understood mean, what is standard deviation, what is variance, how did we calculate mean of each of these data sets. You get mean of A minus mean of B divided by variance, and variance of A divided by the number of values in A and number of values in B. Okay. Now this would be your t value. Now let us assume you are not able to understand even after seeing the video for 10 times. So I'm deleting this. You can note all this down whenever you want to. So what is a t-test then? In simple words, if you are not able to remember all this, what you can simply write is t is nothing but the ratio of two things. Okay, the first thing is difference of means of the two data sets. Okay, and the second thing which comes in the denominator of the ratio is the degree of variability of both data sets. So difference of means of the two data sets divided by degree of variability of both data sets. Okay, so this is what t is. If you do not want to write any mathematical equations, do not use any mathematical symbols. It's completely fine. Nobody will question you because it is a pure social science subject. You do not necessarily need to put mathematics in it. Okay, if you want to write it in words, you can write it as Ttest is the ratio. A Ttest tries to find out the ratio of difference of means of two data sets and the degree of variability of the data in these two data sets. Okay, this is what Ttest is. You can write it in a sentence because psychologists need not necessarily know the mathematics behind it. There are packages. I can write you a formula in Excel to calculate this. So if you have this two data sets A and B, you just give me these data sets. I can write you a formula in Excel. I can write you a program in R, a program in Python, a program in MATLAB, or what generally social science people use, SPSS, Statistical Package for Social Sciences. These are all nothing but computer programs. Okay, so you just feed this data into it, you will get the t value. So you do not need to actually know the math, but it's always better, if you write it, it will maybe fetch you a little more mark. Okay. So what kind of questions they can ask from t-tests? First is what is it? So you have to write this definition. If you remember the formula, you write it. Okay, and you don't actually need to rectify the formula. It's very simple. If you see what I've explained, it's simply if you know what variance is, which I've explained, standard deviation is, what is a mean, then you know what it is, right? There is a technical term for this, degree of variability. So it is you can say it is the difference between two data sets and the standard error. Yeah, the standard error between within the data sets. Okay, so that thing you can write as a definition. Next thing they can ask is where it is used, and in that case you have to tell certain examples, like it is used in situations where you need to know that these two data sets, or what I am getting from in two different groups, is actually making them distinct, right? So if a particular value, the mean comes 195, then just by looking at the mean, I may not be, propelled to say that these two are different. I will have to use a t-test to determine whether these two are different. An example could be, let's say you have got a situation in which you are trying to you are conducting a psychological therapy between two groups. Okay, one is given the cognitive behavioral therapy, and the other group is given just meditation and yoga. Okay, so you want to see which is more effective. So you measure their various physical parameters of their body, and their you take their EEG, ECG, and your all the vital symptoms of the body, and then you segregate them into these kind of data sets, and then you calculate mean of all, and then you calculate t value of all, and then you say whether there is significant difference between this therapy and this therapy or not, the outcomes of these therapy or not. This can be an example which you can cite. Okay, apart from this t value, there is also one more, an associated, a t value has always an associated p value. P value is nothing but a probability value. But I do not think they will go this deep here. They will not ask this much. If they ask, then nobody will know. So you stay nishchint rahiye. Nobody will be asking you this. If in case they ask you, then you can say that p value is a probability value. That's it. Okay. I can explain you this, but I don't think it will come, so I will not. Okay, so I think this is all they can ask. One thing they can ask is where can t-test be used and where they cannot. वो भी थोड़ा deep हो जाएगा, but let's suppose they ask us. So there are many criteria where t-test actually applies and where it does not. But that will be pure statistics. That will not be mean psychology. So that is one point. Is there are many reference cases in which t-test might apply, t-test won't. So your distribution of data has to be a bell curve, right? It should not be skewed like this, or like this. In these situations, okay, leave it, man. I think we are going too deep in this. This is what they will ask. I'm telling you what and where it is used. Okay. Okay. So let's move to the next topic, and that is ANOVA. Okay, ANOVA is what? ANOVA is nothing, it is analysis of variance. What is variance? The square of this thing is variance. Okay, so in what situations can ANOVA be used? ANOVA also is used when there are two different things you are trying to compare between two groups. ANOVA can also be used within one group also. Okay, so your next topic is ANOVA. ANOVA is what? This stands for analysis. This stands for of, and this is variance. Okay. Now, so analysis of variance means what? Variance is what? Sigma square. Okay. I told you what is this, right? This is the, if you subtract individual values from the mean value, square them, okay, and add them up, and then divide them by the number of observation, you get standard deviation, that is sigma, and if you square that value, that becomes your variance. कुछ गलत बोल गया क्या मैं? नहीं, I think I was correct. Anyway, you will correct me if I'm wrong by seeing the first part in which I would have said. You can scroll back and see. Anyway, so let's move to what exactly is ANOVA. Okay. So look, I can again tell you the whole formula of how ANOVA works actually, but you don't need to know it because they will never ask you an exam, and even as a psychologist you won't need it because there are packages which are built to calculate it. I can tell you the formula. It's something related to mean sum of squares and mean sum of squares due to errors divided by mean sum of squares due to treatment divided by mean sum of squares due to error, and then sum of square has another formula, and this due to treatment thing has another formula. You can know all that, but it's not needed. Okay, what you have to know is what is ANOVA and where it is used. It is something similar to Ttest. Okay, but the difference is it is actually used to find out in psychology. It is so what is ANOVA, you know. So it, if question is what is ANOVA, you, it is a method which helps us to find out the difference. It helps us to analyze the variance between two data sets. Okay, this is what ANOVA is: variance of two data sets. Helps us analyze the variance between two or more than two data sets or one data sets or with different levels. We'll come to one way ANOVA and two way ANOVA and explain what it is. So it basically helps us analyze the variance in data, variability in data. Now I'll tell you where it is used, where you know what it is. Now where it is used, you can cite examples. Let's say we can go back to the same theory, same problem we were discussing for t-test, and that is, let's say you have three situations. You are trying to treat schizophrenic patients, and then you are using three therapies. One is cognitive behavioral therapy. Okay, another is let's say meditation and yoga, and the third is a combination of these two, like CBT plus yoga. So you want to find out whether this is the most effective method, or this is the most effective, or this is the most effective. Okay. So in that case, you will measure the emotional states using some kind of an objective criteria. You come up with scores which measure their degree of schizophrenia. Okay, and that score you will put here for each of them. And then what are these points? These corresponds to different patient number 1, 2, 3, 4, 5. Okay, and here patient number 6, 7, because they are all getting different kinds of treatment. One is getting only cognitive behavioral therapy, another is getting meditation and yoga, another combination of both. There can be a fourth control group. You know what a control group is, right? So a control group, इसको कुछ भी नहीं दिया. They are left as it is without treatment for a week or maybe 2 weeks or 1 month period, whatever. So you have 4 groups, and you can actually find out their analysis of variance. Okay, so in ANOVA there are a few concepts. Let me explain you that first, and then we'll move to what is a one-way ANOVA and two-way ANOVA. This is what the maximum they can ask. Okay, so where it is used? It is used to generally determine which of the data sets of an outcome of an experiment. So let me. You can give this specific example that in this situation, ANOVA can be used to determine the most effective therapy. But if you have to write in a more general term, you can write that it is used in cases where we have to find out the difference in the outcomes of a particular experiment, and that is analyzed by subjecting it to subjecting an ANOVA test to the outcome data of those experiments done on different groups. These are different groups. Okay, so now let me explain you a few concepts of ANOVA, on the basis of which I will explain you what one-way ANOVA and two-way ANOVA is. First is level. Okay, level is actually, so let's say if you did not have numbers for schizophrenic patients, okay, you do not have scores like 23, 45, you do not have that. You just had two scores, high and low, like high degree of schizophrenia, low degree of schizophrenia. Okay, then this number of levels here is 2. Okay, similarly, let's say if you are doing an experiment in which you are trying to understand the effect of noise on the stress levels of people. and if there are three noise types, high, medium and low, then you have three levels, right? Now there is another concept which you already know, but I'll again tell you: independent variable. Okay, independent variable is here. Here the independent variable is what? What were we discussing here? The different types of therapies, right? So independent variable is, okay. Sorry, the independent variable is different types of therapies. The dependent variable here is so okay. So levels can be from both for dependent and independent, but we are talking specifically of independent level variables. So let's remove this because this was related to the outcome that was dependent. So independent variable here in this experiment in which you are trying to find out the level of stress due to noise in different people. So the level of noise is the independent variable. Okay. That can be altered, either it is medium, low or high. Now, in one particular experiment, there can be more than one independent variables, right? In the same experiment, let's say you also introduce a component of temperature. Okay, so as there is more heat in a room, people, it's of general observation that people generally try to get a little more short-tempered and stress levels increase. So in that case, there will be two independent variables here: noise and temperature. Right. Now temperature can have more than two or two levels: high, low, or high, low, medium, very high, extremely high, uh, equator level temperature, furnace level, and the low it can have igloo. Okay. Anyway, so the independent variables and levels. So this, if you understand, we can move to what exactly is a one-way ANOVA test and a two-way ANOVA test. So a one-way or a two-way ANOVA test is nothing but uh, almost the same thing. The only difference is in a one-way ANOVA test. Okay. Okay. Before this, in the levels thing, what we discuss in that experiment, in that thing where uh, one group of patients is given only CBT, another group is given CBT plus yoga meditation, another is given just yoga meditation, another is given nothing. In that, the levels are these four things, right? So level one would be only CBT. Level two would be uh, CBT plus yoga meditation. Level three can be only yoga meditation. Level four can be nothing, no therapy given. Okay, so these are all independent variables. Remember, we can choose the experiment method. So the concept of level here is a little different. Okay, sometimes it can get a little tricky. What I told in the a little while before was that level would be their scores in the values. No, but that will be the level of dependent variable, not the independent variable. That dependent variable is the amount of progress there has been in their mental health. That would be dependent variable. But here the level would mean this. Okay, levels are also sometimes called groups in statistical terminology used for ANOVA. It is called groups. Okay, so you just remember this. Okay. Now, one-way ANOVA and two-way ANOVA. One-way, okay, one-way ANOVA means only one independent variable. This is what one-way ANOVA means. Okay, this independent variable can have two levels or more than two levels. It doesn't matter. It can be high, low, medium, super duper high, spectacularly high, whatever. It can have multiple levels or just two levels. Then what is two-way ANOVA? Where there are more than one independent variables. Okay. So this they would ask. Sometimes they would have asked you how does one-way ANOVA differ from two-way ANOVA? So you just have to write this. Okay. But inside this one-way ANOVA also there are a little differences. So something by the name of independent one-way ANOVA is there. By the way, this two-way ANOVA is also called factorial ANOVA. Factorial ANOVA. Okay. Factorial. Okay, so this one-way ANOVA has some types, and one of those types is independent one-way ANOVA. What does this mean? This means that your are you able to see, right? Okay. So this basically means that when we say independent, right, we mean that the whole the experiment that has been carried out, the there would be different participants in this experiment, right? So if the participants are not just one, there are different participants, then it would be independent. That means there would be, let's say there would be 5 people on which this experiment is being carried out. Okay, so this independent variable of noise and stress wala, so there would be different individuals on this is being carried out, and you have data for all. Okay, that would be independent one-way ANOVA. What would be the reverse of it? That reverse would be dependent, but it's not called dependent. It is called repeated measures one-way ANOVA. Okay, repeated measures one-way ANOVA. So, or you can also say it as one-way repeated measures ANOVA. In that, what happens is there is just one person who is subjected to. So, if these 4 persons, all of them are subjected to this experiment for each level. So let's say this guy is also subjected to a low noise level, high noise level. This guy also subjected to low, high, low, high, low, high. Okay, and then their results are measured. Then there will be repeated measures one-way ANOVA. And what would be independent one-way ANOVA? That the experiment would be carried out in all these people, and they will be sitting in a group. Okay, and the frequency would be changed, one low, high, and low or high. The noise would be changed, low or high, and then their reactions would be measured all at once. But if the same test is conducted at each one of them individually and found out what is their stress levels, that would be a repeated measures one-way ANOVA. Okay. Also, why this was called factorial ANOVA is that this word, because this two-way ANOVA is called factorial ANOVA because these independent variables, now sometimes the terminology in statistics gets confusing. This independent variables is also called factor, right? So here noise is a factor. Their type of therapy was a factor. Okay, so this word actually gives this word, that is factorial ANOVA. So you're gonna either call it as two-way ANOVA or you can call it as factorial ANOVA. Okay. I mean, so this is why they are called factorial ANOVAs. Okay, a little while ago I told you that this low, high, so it's independent one-way ANOVA. They conduct it when it is conducted in a so let's say, okay, so there is an experiment you are carrying out in a room. Okay, you call 5 people. Okay, and then you subject them to high noise. Okay, and then you remove these people. Then you measure their stress and you remove these people. Then you bring another set of 5 people, and you give them low value of noise, and then you measure their stress levels. Then send them out. Then that would be independent one-way ANOVA. I'm explaining this because I think I should take time and explain this. Maybe what I explained last time was not a few minutes ago was not properly understandable. It was proper, it was not properly understandable. Okay, so that would be independent one-way ANOVA, where each participant gets only one condition, right? But in repeated measures, you would have every participant go through each level of that independent variable. Okay. Similarly, in factorial ANOVA, we also have this thing, independent factorial ANOVA, or it is also called single measures. When this is called repeated measures, right, then this can also be called single measure. So in factorial ANOVA also we have two things. Okay, so we have two things. One is single measures. Actually, we have three things. Single measure in which there will be more than one independent variable. Let's say there will be heat, there will be temperature, okay, which can be varied in high low, and there can be also one more thing. Let's say, give me an example. Number of spectators in the room, or the amount of space available in the room, those kind of things, or whether they are sitting on a steel chair or a sofa, that, or on the ground like me. I'm doing it right now. So that can also be a one independent variable, also called factor. Okay, so if it is a single measure, that means each participant goes through one condition only one time. That would be a single measure. Okay, is the board visible? It's not visible. Okay, so the two-way can be two-way ANOVA, or the factorial ANOVA can also be of three types. One would be your single measures. Okay, measures in which each participant goes through one level only once. Okay. The second could be multiple measures or repeated measures, right? Repeated measures, and so now you can guess what would be the third type. The third type would be repeated measures. What you got right? Like each participant goes through all the levels of noise. So if there are three independent variables, so you have noise, you have temperature, and you have also type of chair. Let's say you have three levels of each: steel, wooden, and sofa chair. Temperature high, low, medium. Noise high, low, medium. So how many times will one participant have to go through? How many combinations will they have to go through to experience all the conditions? It would be 27. But actually, this is not what I'm talking about. I'm talking about is that each participant will have to go through all these independent variables on all their levels, right? So it might mean that they would have to go through 27 times. But practically that's not feasible, right? If the independent variables increase, right? You got it, right? How did we arrive at 3 into 3 into 3? It's simply, there's a concept called permutation combination. Or simply it is multiplication rule. So if there are high, low, high, low, high, low, so high, low, medium, if you want to calculate the number of sets, I am telling this for non-mathematics people, so those who already know this, please, you can shut your eyes and ears for a while. Okay, so you just calculate the number of distinct conditions that can be. मतलब एक में हो सकता है high noise हो, low temperature हो, और wooden chair हो. एक में हो सकता है wooden chair नहीं हो, steel chair हो, बाकी दोनों condition same है. So that means अगर एक condition यहाँ पे vary कर fix रखते हैं, तो इसके लिए दो condition है, right? तो मतलब यहाँ पे तीन कंडीशन हो सकता है, यहाँ पे दो ही कंडीशन हो सकता है. ऐसे ऐसे लिख के हम लोग तीन ऐसे इसके लिए 9 हो सकते हैं, राइट? क्योंकि आप इसको रख के इस तीनों को मतलब इसको चेंज कर सकते हो, इस दोनों को सेम रख के, इसको समझ रहे हो ना? टोटल तरीके की 27 कॉम्बिनेशन होंगे परम्यूटेशन लगा के. ठीक है, तो 27 टाइम्स गुजरना होगा उस बंदे को, अगर आपको एक्चुअली रिपीटेड मेजर्स अनोवा करना है, फैक्टोरियल अनोवा करना है तो. बट There can be a midway between the two, and that is mixed measures. Okay. Mixed measures or mixture of measures. Okay. उसमें क्या होता है? The participants will go through more than one level, each participant, but not necessarily all levels. Okay. You got the idea of what ANOVA is, right? मतलब इतना बताने के बाद ये डाउट नहीं होना चाहिए कि ANOVA है क्या. It is analysis of variance. Variance in what? Variance in the outcome data. ठीक है. So let's say after all these experiments of control group and experimental group of noise, let's go to the simplest case. This is independent one-way ANOVA, in which we are trying to find out the stress levels क्या हैं लोगों के. Okay, when we alter the noise from low to high, right? Low and high levels पे क्या है? तो एक control group पे the noise was not varied. In the experimental group, the noise was varied. And the stress was calculated. The stress values are here. The noise values are here. Right. So this will be noise will be factor. Okay. Okay. It's not visible. Okay. So noise will be one factor or independent variable. Stress will be the dependent variable. Now, ANOVA has a formula. Okay. If you want me to tell you the formula, I can actually tell you it's sum of sum of squared errors SSE by sum of squared errors by okay, sum of why am I my ego pe kyun likhna? So you can find it out, right? So there is a formula, and so it's ratio of two things. Let's call them S1 and S2. So one is due to, if you go to the beginning of this video, I've actually explained the two. I'm forgetting right now because it's very late in the night. Anyway, so this ratio of these two, and these S1 and S2 further have different formula. Okay, if you want, you can Google and you can see the formula, but there will be no use. Okay, you don't have to write it. You just have to understand the concept. So using this ANOVA technique in a package, statistical package like SPSS, or R or Python, whatever you want to use, MATLAB. Okay, you can, or even C++, you can program a computer to find this out, ANOVA, or you can even use Microsoft Excel. Okay, so you can, if your data set is like within the limits which Excel can handle. Anyway, so this ANOVA will try to, in this case, find out whether the stress levels are actually different in different noise situations or not. Okay, very similar to Ttest. The only thing is that the methodology is different. In Ttest, what we used to do, we used to take a simple difference in mean. Okay, mu1 minus mu2, or in that case, we are taking mu a minus mu b, and we divided it by the standard error of both the data. That means it was sigma square by NA plus sigma square by NB whole ka under root. Right? So it was basically variance. So what we had explained in normal sentence, it is a T-test was the difference between the means divided by variability of the data set. Okay. But ANOVA, and it was also Ttest also tried to do the same thing, but ANOVA does the same thing in a different manner. Okay, it has a different procedure of the calculation of ANOVA. Okay, so this is what it is. They will not ask you anything more than this in ANOVA. Okay, if they ask, nobody will be able to answer. You will also not be able to answer. I have given you what it is. You can give you can give the examiner where it is used. You know what is single measure, repeated measure, mixed measure, right? In two-way ANOVA and one-way ANOVA, you know what is independent and repeated measures. Okay. If they ask anything beyond this, tell them that you don't know, and write in the copy that none of the other people will also know. So it doesn't make a difference. Okay. Now we come to regression. So what is regression? Regression, if I think those of you who would have had mathematics in 11th and 12th would have known that. जो इंजीनियरिंग बैकग्राउंड से उनको तो फर्स्ट ईयर में पढ़ाया भी गया होगा इसको, बट ऑफ कोर्स आपको याद नहीं होगा बहुत सारे लोगों को. आई जस्ट रिफ्रेश इट. ओके, forget psychology for right now. I'll explain you what regression is in general. Then I'll go to a psychological example. Okay, so let's say you are measuring. This is on x-axis. आप घर खरीदना चाहते हैं. Okay, तो on the x-axis there is your number of let's say educational level. So you say number of years, successful वाला years, not failed. ऐसा नहीं कि fail हो रहे 10वीं में 4 बार. So number of years one has attained education. Okay, and here is his income, formal education. Okay, so 0, 1, 2, 3. It can go up to, some people study up to 30 years of age, whatever. 30 years of age also, and 30 years of full academy. People do double MA, triple MA, whatever. PhD in 2 different topics. And so you have some points here. Okay, so there are some people with only 3 years of formal education, their income is here. Of course, I mean, it is so these points are different people. So you measure their education level and measure their income level. So you will see that in general, these people, it might be that someone with 6 years of education only, that means वो बस 30 class तक पढ़ा है, and then you would be earning here. Okay, very high. But in general, here it will be low. But with income, with higher education, it will start to increase. आप कोई डबल PhD किया है तो some really good research institute would pay them, or scholastic people would pay them, right? But of course, ऐसा भी हो कि कोई PhD है but double triple PhD है but they would become alcoholic or they would suffer from a disease, तो उनका income 0 हो जाएगा. ठीक है, यहाँ पे आ जाएगा. But in general, it will follow a pattern. तो आपको ये लाइन दिख रहा है धीरे धीरे ऊपर बढ़ रही, right? Now regression, what it basically does is that it tries to find a pattern in a data. So regression is nothing, it's a pattern between independent variables and the dependent variable. Here the independent variable is education level, dependent variable is income, right? In this there can be many types of, so in order to find data, what will you do? You will, यहाँ पे आपको लाइन जैसा कुछ दिख रहा है. If I try to draw like this, आपको एक दिख रहा है ना लाइन, काइंड ऑफ इसी पैटर्न में बढ़ रहा है. So if it is a straight pattern, straight line pattern, you will call it linear regression. Of course, many points will not fit into this, right? But it shows a general trend, right? So tomorrow, if you meet someone with 20 years of education, formal education, you can approximately say that his or her income level would be this much. Of course, there can be outliers, but you can say that with a good degree of accuracy. Okay, so this is what regression is. If it's a straight line, it will be linear regression. If in the same thing, if you find this kind of a thing, this is a parabola. Okay, that was at so let's say if this is not 30, this is something else. This is 10 here because 40 years का education तो कोई करता नहीं है. 30 here. Okay, so what we are trying to say, if you study formally for around 16 years, then your income will be maximum. उससे ज़्यादा पढ़ोगे भाई तो actually तुम्हारा income कम होगा. So this is your optimum level of income. It's a hypothetical situation, okay? Suppose the data says that, okay, that after this point, if you study more, your income will decrease. Let's say if it says that, okay, then this is a parabola. Those who know mathematics will know that a parabola is a quadratic equation. Quadratic means, so इसमें देखो linear equation मतलब straight line मतलब 1 degree equation मतलब y is equal to mx plus c. ओके डोंट वरी, ये इसका नहीं समझ में आ रहा मतलब तो कोई दिक्कत नहीं है. बस इतना समझ लो कि डिग्री 1 इक्वेशन है, मतलब लीनियर इक्वेशन मतलब डिग्री 1 मतलब स्ट्रेट लाइन. ठीक है. डिग्री मतलब यार यही होता है. देखो ये x टू द पावर 1 है ना, राइट. इस लाइन का इक्वेशन, स्ट्रेट लाइन का इक्वेशन x टू द पावर 1 के टर्म्स में लिखा जाता है. अगर ये पैराबोला है तो ये डिग्री 2 हो जाता है. ठीक है. इसका इस टाइप का आ जाएगा ax स्क्वायर प्लस bx प्लस c. ये कोई भी कॉनिक हो सकता है, पैराबोला, हाइपरबोला, इलिप्स. सो बट या पैराबोला का इसी फॉर्म का इक्वेशन आपको मिलेगा. y क्या है? इंडिपेंडेंट वेरिएबल. x क्या है? डिपेंडेंट वेरिएबल. ओके. a b and c are constants. It can be any value, -2, -39, plus 1006, whatever. Similarly, m and c are constants which determine this line. So if you give the value of x here is 20, it will, and these would be constants, it will tell you what would be the income. Similarly, if you give the value of x here at these two places, it will give you the value. So this would be one is linear, then is binomial, but we don't say binomial. Anything above degree of 1, because here the power is 2, so it would be degree 2. Anything above power 1, we call it as multilinear regression. Okay, so this is what it is. Regression yahi was. If you want to go into mathematics, I can go, but there is no use at all. I can tell you how linear regression is calculated by sum of least squares method, okay, and where it is applicable, where it's not. But this is what it is. This is what you should know. Linear regression, multilinear regression means when the curve is not a straight line, it will be, when the curve fit would not be a straight line, it will be multilinear regression, or not multilinear, what am I writing? Multinomial regression. Okay, sorry, multinomial regression. Okay, so if anything more than 3 would be that. So agar anything more than 1 degree would be that. So ax cube plus bx square plus cx plus d would be a third degree equation, right? So that would be a third degree polynomial, and that would also be a multilinear regression. These both would be multinomial regression. Sorry, yeah. So this is what regression is, and I was telling you some important thing, and that was, if I'm not able to remember, it won't be important anyway. So in psychology, where do we use this? So let's say you have experiment in which you want to find out, you do not have, abhi to dekho, you only collect data for sample population, right? You cannot go to each and every individual and find out what their, whatever their data is, right? So it will be helpful. Okay. This thing I'll tell you later, but another important thing I was telling you, which I said I forgot. That is, here we are considering only one independent variable, educational level. But a regression can also be run on more than one independent variable, right? So there can be educational level plus health plus IQ plus emotional quotient. Maybe these 4 are the most important variables which determine your income. So still these 4 variables can give you a line, but वो 4 डिग्री में इमेजिन करना मुश्किल हो जाएगा, राइट? आप ऐसा समझ लीजिए 4 डायमेंशंस में कि इसके लिए एक इक्वेशन है mx plus c, ठीक है, m1 x1 plus c1, लीनियर रिलेशन बोल रहा हूँ मैं. हेल्थ के लिए अलग है m1 सॉरी m2x plus c2 iq के लिए अलग है m3x plus c3 and eq के लिए अलग है m4x plus c4 okay so this would be a linear regression which takes into account all these independent variables and tries to find out my y, that is my income. Okay, so if I tell you, so let's say if you are doing an experiment, a social experiment in psychology, in social psychology, in which you are trying to find out ki how does, you have heard about McClelland's experiment, right? Kakinad experiment. If you're not, you should read. It's a very famous experiment. So what McClelland did is that he measured achievement. He related achievement motivation with income level or prosperity of a country and also individuals. Aim is what? Aim is achievement motivation. Aim also means something else. I won't tell you. Achievement motivation. Okay. So let's say if you know achievement motivation of people and educational level of people, and you are trying to find out, you are doing research on motivation, and you are trying to find out whether achievement motivation has a direct relation on income or not. What you will do, you will collect a sample of people. Okay, here will be name of people: Raju, Sham, okay, Babu Bhaiya. Okay, and here will be their educational levels: graduate. No, Sham was a graduate, right? This is 10th pass, and he is illiterate. Okay, and then you have achievement motivation, highest. Let's say he'll be getting 10 out of 10. Here it would be 8 out of 10. Here it would be 4 out of 10. Okay, and then you will be calculating income of these people. Okay, so this is like 1,000 rupees, 25,000 rupees, 1 lakh rupees. So you try to make sense of this data and try to find out the factors. वो मैंने लिखा था ना m1x plus c1 m2x plus c2, right? ये सब लिखा था ना. So these m1 and m2 are basically factors. तो ये if m1 is greater than m2, so let's say 1 means education, m for education is greater than m for achievement motivation in the whole equation of the linear regression, then we would say that education has a higher effect on income than your achievement motivation, right? Okay, that's true. If it is complicated, don't worry. If you are not able to understand, it's all right. What I'm trying to tell you here is he will get only, the researcher will get only, let's say 10, 15, 20, 100,000, 2,000, at maximum 10,000 people on research, right? But he cannot go to population of India, which is increasing day by day. Okay, more than 100, 125 crore देशवासी हैं हम लोग. So we cannot go to the whole thing. So what we can do here is, if you collect a data of limited number of people, if we come up with an equation which almost approximately represents relation between education, achievement, motivation, and what did I write here? Oh, this is in, okay. So there's two of them. One equation tells you about education, another equation tells you about achievement, motivation. You add these two; these are equations, and you get the income. So once you have these two values for anyone, you can predict their income. So this is what it is done in regression. You find a pattern, and you use a prediction methodology. Okay, and then you can use that data set for another kind of research. This is what regression is, boys. Okay, I don't think you need more than this, more deep than this. Okay, you don't have to worry about the formulas or how it is done, exact method. It is, for example, linear regression is done by sum of least square method. Multinomial regression is also something similar. But all these, so if you just put these data, the education level, achievement, motivation, and income of people, put in packages like SPSS or R or Python or MATLAB, you can also run regression in Excel. So you basically, if you plot these scatter plots in Excel, do a right click and say add trend line option. Those of you have a licensed version of Office, you can do that. Open Microsoft Excel, put Raju Shyam's data, education, achievement, motivation, and then you will get some put insert chart, you will get scatter plots, then do a right click on that plot and then say add trend line. Okay, then you will get an equation. So check the checkbox, display equation on chart, you will get the linear regression, or what you can check whatever you want. Select either you want linear regression or 2 degree, 3 degree, 4 degree, whatever. Okay, it's very easy, so you don't need to remember the formula. When it can be done by the machine, why does human have to do it, right? Human is for creativity. Okay. Okay. So this is what it is for regression. Next is factor analysis. That is also very important. They ask a lot of questions. What will they ask in regression, by the way? They'll just ask what is it and where it is used. Give some examples. That's it. Okay. What are the problems? The problems can be, it might not be very accurate at times and might give faulty representation. So if you have to tell in one sentence, regression is nothing but a method to find relationship between the independent variables and the dependent variable. Okay, this is what regression is. Coming to factor analysis. This can be a little confusing, so थोड़ा ध्यान से सुनिए. I'll start with an example. So let's say you are trying to measure intelligence of people. Okay. So you are trying to measure their IQ or something like that. You are a new researcher who wants to invent a new method of measuring IQ. Right? Your method, what it does is it tests their knowledge in the field of language. Okay, you make them read, write, and listen. Then you check their mathematics, arithmetic capability, differential equation solve kar pa raha hai ki nahi, whatever you want to check. These are the people: Raju, Shyam, Babu bhaiya. Okay. Maths, language. Then you check their reasoning abilities. Then you check their spatial abilities. Then you check their musical abilities. Then you check their dancing abilities. You have a lot of this. So when you analyze, there will be more people like this. Okay, you have thousands of data points. Now, what in your analysis, without using any software or anything, you see that whoever has high score in language category, also, I'll just give you an example, also has high score in music category, musical intelligence. And those who have high scores in what was this? Spatial intelligence also have high intelligence in dance. Okay. Similarly, those who are good in reasoning, right, are also good in maths. Let's say. So you see, actually, your different kinds of columns are not different kinds of columns. They are actually one or the other factor. So you can actually combine each of them into smaller set of variables. Maybe you can just have 3 types of intelligence, A, B, and C, and you just need to measure this. So you did all this, and then you find out that many of this is related to just pointing to one thing. Many of these things sync or sail together. Their correlation is very high. So you get this 3. So what you did, you found out 3 factors, A, B, and C, which determines your IQ. This is what is factor analysis was. Okay. There are programs, there are computer packages which are trained to do so. You cannot do it manually for a large set of data, right? So to give you a formal definition, factor analysis is nothing but a statistical procedure to find groups of data within a set of observed variables, a set of underlying groups, within a set of observed data. ठीक है. So This is what factor analysis is. It's a statistical procedure to find out underlying groups. Now, I'll tell you what are the benefits of this. Questions that can be asked. One is what is it? Second is where it is used, and it has actually come in what situations does factor analysis become necessary. So, in what situations will it be necessary, right? Think about it. In situations where there are a large number of variables concerned, it becomes very difficult to work, right? So let's say if you are researching on what exactly determines the the intelligence of a person, and you go to every take all possible data you have. So you take their income, education level, their family background, number of people in their family, their state of their health, how many, whether they wear specs or not, what you know, you take countless number of variables, but in the end, when you sit with that data, बोले ये क्या है भाई इतना सारा कैसे करूँगी मैं? Then you run a factor analysis, and then you actually see that there are just three factors which determine the IQ, and those are A, B, and C. You know, people who, let's say you find out, I'm not saying this to the people who wear specs, actually their health is also bad generally, or something like that, you know. So you just out of those thousand sets of data, you just came out with uh, just a few of them. So this is a situation in where it can be useful. Now they can ask you what are different types of factor analysis. So first one is exploratory type, exploratory factor analysis, and the second is confirmatory factor analysis. It is clear by the name, right? Exploratory means where you don't know that how many factors are there, right? So in that intelligence for example which I was giving you, you did not know that how many. You just measure. You tried to find a new definition for IQ. You took many columns. You did not know how many actually factors are there. Uh, after seeing the data, you found out okay, there are just three factors. But let's assume that there is a situation in which you already know that there would be three factors or five factors. So in the first case where you don't know how many factors there would be, that is called exploratory factor analysis. And the second type it will be called confirmatory type. So an example of the second type can be, let's say there can be just two groups of people, right? So there are lots of variables. So there can be just two groups of people, one who are prone to cancer and another who are not. You take their habits, whether they smoke or not, whether they had a genetic problem of cancer in their history or not, their general health condition, their physical activity routine, their lifestyle. You take all those status. Now you know that there are just two factors. Factor would be A and B, whether they have cancer or not. Actually, this is not the most appropriate example, but you can use this, right? This is more of a logistic regression, but uh, but you can use this. That there are actually just three factors. Let's say there are just three factors which contribute to cancer. One is your the food you eat. I'm just giving example. Second is the genetic factors, and third is the atmosphere you live in. So in these genetic factors, there can be number of family members, your health condition will also be related to this. In this food, there can be where do you live. So where do you live actually determines a lot of times what is your food, and also atmosphere. So you are understanding out of a lot of things, you just know that there are only three factors: food, genetic makeup, and the atmosphere or the environment where you live, which contributes to cancer. Now you try to find out, segregate all those variables into these three groups. That is called confirmatory factor analysis. Okay. Now, see, I mean, this is what they will ask from factor analysis. Apart from this, they can maybe ask you examples. So if you go and read intelligence chapter, now, there is a lot of use of factor analysis there. For example, Charles Spearman has given a theory about G factor and S factor, something like that. So he concluded that one is general factor and one is specific factor. The intelligence can be grouped into general intelligence, where it applies to every task, and specific, where it is musical or dance wala, or So if you go and read intelligence chapter, you will get some examples about factor analysis. This is what they will ask, nothing more than this. If they ask anything more than this, tell them, I don't know. Okay. There are packages like SPSS, Statistical Package for Social Sciences, which are inbuilt computer programs to do this factor analysis. So you put data in them, they will tell you how many factors it has. Okay. It is similar to clustering actually and classifying. Okay, anyway. Okay, so you can write to impress the examiner SPSS R. R is a language. Okay, that also has packages for factor analysis. Then Python is a computer programming language, very popular these days. Okay, you can use all these. You can also use MATLAB, Paint. Okay. Now we come to our last topic, and I know it's getting late, but it will not be very. I will not keep you very late now. It would be item response theory. I don't know why they have added this at random in the syllabus, because it just seems out of place. But still, I will tell you because it's written. So in general, how is a test? If you have given any entrance examination, let's say civil services, तो prelims तो दिए ही होगी बहुत सारे लोग आपने से. So every item has equal marks, right? But item response theory actually tells that is not the best way to find out the results of an exam. Rather, what we should do is each question should have different marks. ऐसा नहीं कि 100 क्वेश्चन है तो हर का 2 मार्क्स और 110 जा रहा है कट ऑफ, तो मैंने 55 बना दिए तो निकल गया. No. So what it should be that each item in the test, that means each question should have a different marks based on the difficulty level, or there are 2 factors. One is called so item theory, what it assumes is that the probability of the answer being correct depends on 2 factors. One is the person factor, and another is the so person factor or individual factors, you can also call it. Okay, and the second one is the item factor or item parameter. So parameter कर देते हैं इसको, item हटा के. I will use boards in all my videos now because it makes things easier for me and you, both of us. वैसे भी मेरा थोड़ा देख के बोर हो जाते हो. Anyway, so this person factor and item person parameter and item parameter. So it says that the probability is the probability of one question, a particular question being correct. Okay. So it says that whether it will be correct or not depends on 2 things. One is the person. Okay. So matlab, if it is a question about GS ka geography in prelims, so whether this person has whether geography is a subject or how much geography has he studied, kind of thing. General intelligence of person, उसकी तुक्का मारने की capability कितनी है, those kind of things, that comes under person. And another is the item parameter. So item parameter means that particular question, how difficult or how easy is it. Okay, so what they do, they conduct, so this is not done in IAS exam prelims, but they do a lot of it in GRE, GMAT, graduate record examination, graduate management aptitude test, right? And there are lots of other tests which use this. So if you have 100 items means questions, each of them will have different marks. One will have 2, one will have 5. And GRE अगर किसी ने दिया होगा आप लोग में से तो देख होंगे, जैसे जैसे आप सही बताते जाते हो ना, लेवल बढ़ाते जाता है. It's a computerized exam, and you won't even know how much marks does this test, does this question contain. In some tests you know, in some tests you do not. So it is said that it is a better method of measuring things. It can be used also in IQ and other, but it is generally used for competitive testing. This is what item response theory says. I mean, if you want to know a little more detail about it, so for each item parameter, now, for each item, they conduct a huge amount of tests. So as and when the tests keep happening. So let's say someone scored 110 out of 200 in the test. Now you see how many of them. So each question. So how many people have given correctly. So if there is one item in which, you know, but this is done before the actual test. This is done on sample population just to check, right? So if 50% of the people have got it right, so it's just average item question, right? But if only 30% of people have got it right and 70% have got it wrong, then it's a difficult question. If it is only 5%, the value would be higher. So that is conducted well before the real test is conducted. This is conducted on different participants, and then it is inducted into GRE or GMAT. And also, as and when the results of these come, they are redesigned. Okay, so it's a very intelligent. So इसलिए आपने देखा होगा कि जनरली जो लोग GRE वगैरह देते हैं उनके स्कोर ज़्यादा वेरी नहीं करते हैं. वो एक बार देते हैं तो फिर भी 330 ही आता है, दूसरी बार भी देते हैं तो भी 330 ही आता है. In recent times, I think CAT, our own IIM wala exam, they have also started to use item response theory. So, what questions can be asked in UPSC in this? What is item response theory? So, you can say that item response theory is a paradigm. Paradigm is what? A new way of thought or something. Item response theory is a new paradigm of test taking, which says that each item should be scored, each question or item should be scored differently than the other depending on the difficulty level, and it has to, where it is used, it will be used in GRE, GMAT and high stake examinations like this, and then to ensure reliability. So what does it do? What are the positives and negatives of this? Positives they can ask, so you say high degree of reliability. That means if you have studied research methods, you know reliability means एक बार एक टेस्ट कंडक्ट किए तो अगर 100 आ रहा है तो दूसरी बार भी करेंगे तो 100 ही आना चाहिए. That is a reliable test. And item response theory gives reliability. IAS जैसा नहीं कि एक फर्स्ट अटेम्प्ट दिए तो प्रीलिम्स भी नहीं क्लियर हुआ, सेकंड अटेम्प्ट दिए तो एकदम रैंक 2 आ गया, या वाइस वर्सा, right? So then if that happens in UPSC examination, it's not reliable, it's unpredictable, right? So item response theory or IRT gives you some amount of reliability. It also helps design tests for high stake examinations, and many people support this. Negativity can be, it takes a lot of time to come up with these tests, and some people also say that there is some degree of subjectivity involved even if you use this method. So there are many criticisms. So they'll ask what is it, why it is used, because to ensure reliability. And again, if they can also ask the same question in different manner, positive and negative thing, they can ask where it is used, GRE, GMAT. So I think this ends our whole research methods chapter with the end of item response theory. I believe that I have done justice to you guys. If I have not been able to do, I'm sorry, this is what I could have done, and I have done my, not the best, but yeah, I have done a good amount of, I put in a lot amount of effort to do this. Okay, I hope you will have benefited with this. I may not be posting any more videos now because I think all other chapters are very well explained in the standard books. Okay, please study hard. This was one of the chapter number 2 and 3 of the syllabus were the two, which this is video number 5 of this chapter 2 and 3. I hope it really helps you. Rest of the chapters are given in standard books and NCERT. So either you can use Barron, Ciccarelli, Morgan and King, Atkinson, whatever you want, okay? And supplement it with the NCERT, make your own notes. So this is the 5th video of the statistics thing, research method chapter. एंड दैट कंक्लूड्स इट. ओके, अब आगे देखेंगे, भगवान चाहते हैं, आप लोग चाहते हैं कि नहीं, किसी और सब्जेक्ट पे वीडियो बनाना. ओके, ऑल द बेस्ट. Have a great UPSC 2018 or 19, whatever you're going to write, or 2021, whatever. All the best. Bye. You have any questions, write in the comment. I'll try to answer.